So welcome back sa ating YouTube channel. So yun, para ang bagong ligo na ewan dahil sa pawis, no? So in this video, pag-uusapan naman natin si Divergence Theorem. So again, ito ay isang way para ma-solve natin yung surface integral. So yung naituro ko from the previous video is yung long method. So actually, yun yung talagang general method o general steps or solution natin o way para ma-solve natin yung isang surface integral. So, kung gusto mo kunin yung surface integral niya. Pero merong isang bagay. So, what if ganito yung tanong. So, the following theorems provide an easier way in the case when sigma is a closed surface. That is when sigma is bounded solid in R3. Again, that is a bounded solid in R3. So, ano ibig sabihin nun? Ibig sabihin lang na something na ito yung mga surface na kung saan may formula na tayo sa volume. So, for example, yung sphere. Kung sphere siya or bounded siya sa buong sphere, so kumbaga yung sigma is bounded dun sa buong sphere na yon. Ano yung formula ng sphere? Actually, so kung naalala mo, sir, ang formula ng sphere o yung volume ng formula ng sphere is just 4 over 3 pi r cube. So, ganun lang. So, meaning, gagamitin lang natin yung volume. So, instead mag-integrate ka, hindi ka na mag-integrate. So, again, si divergence theorem is something shortcut pero merong mga limitation. So, again, limitation niya is something na yung sigma is closed surface. That is, so, kumbaga, when sigma is a closed surface, that is when sigma is bounded solid in R3. So, siya yung mismo. So, ano ba pinagkaiba dun sa mga previous example natin? So, sa mga previous example kasi natin, yung sigma natin is something na, tulad na to, something part lang na yan, plain lang siya sa taas, ayun lang. So, hindi siya totally bounded solid. So, kunyari, buong prism siya. So, syempre, volume na lang ng prism or triangular prism. Pero, ang sabi lang niya is sigma is just yung nasa plane. So, kumbaga, sigma is the part of the plane x plus y plus z is equal to 1. So, part lang talaga sa actually nung plane na yan. So, part lang siya nung plane na yan, andun na siya. So, hindi siya buong solid. Okay, so what if yung sigma natin, kunyari, sphere siya buo, or paraboloid siya or something na ellipsoid siya. So, ayun na. So, yun yung part na hanapin mo na yung volume. Ano yung volume ng ellipsoid? So, ano ba volume pag ganito? Ano ba volume pag triangular prism? Ano ba volume pag truncated triangle? So, something mga ganun. So, kunyari volume ng rhombus o ng rectangular parallelepiped. So, yun yung mga part na yun. So, madali siya. Okay, so, balik tayo dito. So sabi na let's have a theorem, no? So theorem 4.5.1, so the divergence theorem. So let sigma be a closed surface in R3, so which bounds a solid S. So yun na, solid S na, no, pinag-uusapan, no? Which bounds a solid S. So meaning nagre-represent solid S. And let F be a vector field function. So vector field. So ayun na, alam niyo na kung f of x kamo, ayun na, vector field siya. Defined on some subset of R3 that contains sigma. So assuming contains siya nun. Then, the double integral of F dot d sigma. So again, similar pa rin naman yung formula, no? So from the very beginning yata, isa lang yung formula. Or no, magkaiba naman. Okay, so ang integral niya, so again, pag vector field yung given. So ang double integral o yung surface integral natin, pag vector field f yung given, is simply a double integral along the surface z of f dot d theta. Again, f dot d theta. So, kunin ko yung derivative nito with respect dito. So, syempre, instead na gawin natin ganoon kasi hindi natin alam yung sigma na yan, rather, hindi pala theta, yung sigma na yan. Ang gagawin ko lang is just simply equals sa triple integral ng divergence of f dB. Again, that is triple integral divergence of f dB. So, we're in ano yung divergence of f? Divergence of f is just equal sa partial derivative ng f sub 1 with respect sa x plus partial derivative ng f sub 2 with respect sa y plus partial derivative ng f sub 3 with respect sa z. So, yung part mismo ng ating vector field, so partial derivative ko. Tapos, ayun yung ating divergence. Tapos, yung dB. So, ayun yung sinasabi ko. So, whether ano lumabas sa divergence natin, so usually sa divergence lumalabas number or something na gano'n. Yung sunod nating part na gagawin is something na yung integral na ng dB. So, may instances kasi na si divergence is constant. So, if divergence of f is constant, okay, so ang mangyayari is something na yung divergence of f lalabas doon, then triple integral along the solid S nung dB. So, meaning ito yung nakadepende. So, kunwari sphere siya. So, alam kong sphere siya. So, ano yung triple integral niyan? Along doon sa solid. So, yung volume ng sphere. So, that is 4 pi r cube over 3. So, ganun lang. So, ano ba? Rectangular parallelepiped siya. Ayun yung gagamitin. Okay? So, again, div of f or div of f is just equal sa divergence of f. So, di mo pwede sabihin div of f. So, that is divergence of f pa rin naman talaga. Okay, so ganun lang yung formula na gagawin natin. So napakasimple nito. So again, kailangan ma-realize mo or mapansin mo na, okay, solid ba siya? Buong figure ba siya? So okay, go, gagamitin ko si divergence theorem para right away tapos tayo. So pasok tayo dito sa example. So medyo mabilis lang din talaga tong video na to. So let's have an example. So evaluate the double integral along the region sigma or the surface sigma of f dot d theta, where f of x comma y is x sub I plus y sub j plus z sub k is a vector field. Alam natin vector field yan. And sigma is the unit sphere. So again, yung sigma daw natin is the unit sphere. X squared plus y squared plus z squared is equal to 1. Okay, so ano ang gagawin natin pag ganyan? Siyempre sir, una isulat natin yung divergence of f. So sabi po kasi ng formula mo sir So ang sabi sir ng formula mo is yung double integral along the sigma nung f dot d sigma, so puro sigma na lang, is equal lang naman sa triple integral along the region S nung divergence of f. Okay, divergence of f dB. Okay, so yan yung magiging result. So, note, kunin natin yung divergence of f. So, ano yung divergence of f natin? So, for the divergence of f, ito yung f natin, no? So, divergence of f, napakasimple lang yan. Divergence of f is just equal sa, yung una is partial derivative nung f natin. So, ito yung f sub 1 natin dito. Yung f sub 1 natin is x. Yung f sub 2 natin is y. And yung f sub 3 natin is z. Okay, so partial derivative of f sub 1 with respect sa x. So, partial derivative ng x with respect sa x is just 1. Partial derivative of y with respect sa y is just 1. So this is plus. Partial derivative of z with respect sa z, that is simply 1. So meaning the divergence of f is 3. So constant. Okay, so kaya nga pasok dun sa sinasabi kong constant. So meaning, ang equivalent form sa taas, this is just equal sa lalabas ko lang yung 3, this is 3, the triple integral along the solid S nung dB. Okay, so note na ang solid natin, so yung sigma law natin is a unit sphere. So since unit sphere siya, which is x squared plus y squared plus z squared, so center siya sa origin. So alam mo na ang center niya is origin. Ano yung radius niya? Ang radius na itong unit sphere natin is 1. So again, ang radius ng unit sphere natin na yan is 1. Kasi square root ng 1 is 1. So ang radius na is 1. So meaning this is just equivalent lang. So again, by divergence theorem na to. So by divergence theorem, this is equal sa 3 times the volume of S. Any volume of S. So this is just equal sa volume of S is just equal sa multiplied by 4 pi over 3. Tapos ano yung R cube? This is R cube. Ano yung R? R is just equal to 1. So this is just simply equal sa 3 over 3. That is cancel. That is 4 pi times 1 cube. So this is just equal sa 4 pi. So meaning, the integral ng part na yun is 4 pi. So imagine mo, iniwasan ko yung mahabang method. So again, gagana lang yung method na to o yung divergence theorem pag sinabi na yung sigma is solid solid siya. So something solid na buo. So buong solid. So ang idea na is hanapin mo yung volume. Okay, so may kanya-kanya kasing volume yung mga yan. So hindi ko na pwede ibigay kasi nasa inyong solid mensuration yan. So I don't know kung tinuro lahat or what. So something na siyempre i-search mo na lang din kung kinakailangan. So now let's evaluate ito naman. No? So what if sir kakaiba yung ating f? So sorry, similar question. So evaluate the double integral along the surface or over the surface sigma of f dot d sigma where f of x comma y or the vector field f is equal to x cube I plus y cube j plus z cube k. And sigma is a unit sphere x squared plus y squared plus z squared is equal to 9. So then, ano yung unit sphere na naman? So obviously, ano yung unit sphere natin na yan? Center at origin, tapos ano yung radius? Ang radius natin dito is 3. Kasi square root of 9 is 3. So now, proceed tayo ulit dito. So for the solution, this is the double integral along sigma nung f dot d sigma is equal sa triple integral along S nung divergence of f then dB. So note na kunin mo kailangan yung divergence of f. So napansin nyo ano yung divergence of f natin? Ang divergence of f natin dito is just dB of f is just equal sa partial derivative ng x cubed with respect sa x is just 3x squared. Then plus partial derivative ng y cubed with respect sa y is just 3y squared. Partial derivative ng z cubed with respect to z is just plus 3z squared. So wherein I can factor out 3 and this is something x squared plus y squared plus z squared. But given yung unit sphere, so the unit sphere na x squared plus y squared plus z squared is just equal to 9. So this is just equal sa 3 times 9 which is equal sa 27. So meaning the divergence of f is 27. So meaning, proceed tayo dito, this is just equal sa 27, labas ko yan, then triple integral ng s dB. So this is just equal sa 27 times the volume of S. So wherein the volume of S is just equal to 27 multiplied by 4 over 3 pi. Ano yung R? R is 3 raised sa 3. Okay, so similarly, this is just equal lang naman sa cancel yung isang 3, no? So may 9 na lang dito. So 9 times 27, nakalik mo na. Nakita na. So 9 times 27, kasi dito 3 cube over 3, so 3 squared na lang siya. So 9 times 4 times 27, so 9 times 4 times 27, that is 972. So this is just equal sa 972 pi. Okay, so yan yung ating value o yung kanyang double integral. So tandaan, gumagana lang to pag solid siya. Gagana lang, gagamitin mo lang sa divergence theorem pag nakita mo siya na solid. Okay, so and last something ito, no? So in physical application, the surface integral over the region, the surface integral, double integral of f dot d theta is often referred to as the flux of f. So ganun. So pag nakuha mo yung surface integral, nire-refer siya as the flux of f through the surface sigma. So flux. So something sa physics to. Okay, so the term divergence comes from interpreting divergence of f as the measure of how much a vector field diverges from a point. So that is the divergence of f of x comma y comma z is just equal sa limit as 1 over b as b approaches 0 times the double integral or the flux. So meaning limit ng 1 over b as b approaches 0 times the flux, which is yung ating surface integral. Ayan. Okay, so yun yung ating divergence. So something na explanation about kay divergence. Ayan. So now, syempre meron tayong theorem dito. Okay, so proceed tayo dito, no? So if the flux of a vector field f is 0 through every closed surface containing a given point, then the divergence of f is equal to 0 at that point. Okay, so again, kailangan natin siya i-prove. So kailangan ko siyempre kahit paano dito na siya. So pakita natin siya dito. So by formula 4.3.33. So ano ba yung formula ng 4.333? Ayun. So ito yung proof natin. Okay, so at the given point, x, y, z. Okay. So by this definition, by the definition of divergence, we have the divergence of f of x comma y. So f yan, f na ganyan. F of x comma y comma z is just equal sa limit as b approaches 0 ng 1 over b. Then the double integral along sigma, along the f dot d sigma. Okay. So note, ano magagawin natin? So aware tayo na for close, so for example, closed surface siya. So assuming so kunyari yung ating vector field, so if the flux of a vector field f is 0 through every closed surface containing a given point. So closed surface, so since sigma is a closed surface, okay, so ano gagawin mo pag sigma is closed surface? Pwede kong gamitin si divergence theorem. Okay, so again, pwede kong gamitin si divergence theorem. So, in which, so, ayan nag-exist to. So, alam ko na yung sigma is a closed surface. So, now, ano ba yung integral ng f of d theta? So, double integral along the sigma ng f dot d theta. Ano ba integral niyan? So, ang integral nito is just 0. Again, 0 siya. So, bakit mo nasabi na 0? Ano, bakit ba nasabing 0? Sabi na, if the flux of a vector field F is 0. So, since the flux is 0, so since the flux is equal to 0, then yung ating yung double integral along the sigma nung f dot d sigma is just equal to 0. Kasi sabi nga natin, no, we often refer the surface integral na ito as the flux. So if the flux is 0, therefore ito ay 0. Okay, so meaning this is just 0. So this is just equal sa limit as b approaches 0 ng 1 over b multiplied by 0. So which this is just equal sa limit as b approaches 0 ng 0, which is this is just equal sa 0. So then, ano yung goal natin? Ano yung na-prove? Then the divergence of f is 0. So ano nangyari? The divergence of f is just equal sa 0. So therefore, this is done. Okay, so ganun gumagana yung mga proving dito sa ating calculus, especially dito sa ating divergence theorem. So again, para lang reminder para sa inyo, no? So reminder lang para sa lahat na ang divergence theorem hindi basta-basta pwedeng gamitin. So gagamitin mo lang si divergence theorem whenever na alam mo na yung sigma o yung ating sigma, yung surface natin is a closed solid figure. Again, a closed solid figure. So baka kasi isipin mo, sir, meron akong elliptic paraboloid pero butas. Alam mo yung parang baso ng elliptic paraboloid or something na parang basta something na baso pa gano'n, tapos baloktot na something. So, hindi pwede yung butas yun eh. So, hindi mo siya pwede mo consider na close. So, yung pwede natin consider na close is yung rectangular parallelepiped. So, basta as long as close lahat. So, wala siyang butas, walang hole, parang gano'n. Okay, so walang lagayan, walang gap. Something na ganyan dapat yung gagamitin. So, mababasa mo naman kung ano yung mga given minsan. Okay, so that's all. Thank you for watching. So again, ang ikli ng divergence theorem. So it is supposed to be nasa loob ng surface integral, pero gusto ko ihiwalay siya para ma-appreciate mo yung part ng surface integral, yung general way ng pag-solve ng isang surface integral. So again, thank you for watching.